Good. So again, guys, we covered U-substitution a little bit, and the idea is to reverse chain rule. So when you see derivative of a function f composed with g times g prime, what is this? This is the same as just reversing. When you reverse it, look, think about what you do. You first eliminate the g prime, and then you have f prime gx. And then the next step, to go back, you just write f gx. So notice what happened here. All that you really did was to reverse f prime back to f. That means all you have to guess is the antiderivative of the outermost function. This is also accomplished by a technique called U-substitution, where u is the inner function. You see, you take u to be the inner function, then du dx is g prime, and then du is g prime dx, just multiply by dx on both sides. What do you get? You get integral f prime gx, g prime x. Yes? And if I replace it by u, if this is u, then this is du. And all this technique accomplishes, I hope you see that, it makes you look at the outermost function. It tries to make it mechanical. What we hopefully realized is that you only need to integrate the outermost function, only f prime. Now let's practice it, please. First, by any means possible, do you see this integral, guys? Root of 2x plus 1. Very quickly, tell me the antiderivative. As quickly as you possibly can, we will do it in two ways. All right, let's see how to do that together. So here is way one, without U-substitution. You have to look at this expression and realize what would you have liked to see. Guys, you see that it's not root of x, it's root of something inside of root of x. And so you hope it's chain rule. So here is that inner function, and then you put a box. The box is empty right now. There is an empty box, you just don't see it. Just like there was an empty box over here. You're just not seeing it. So what do I place in that empty box? Clearly, I want the derivative of the inner function. I want to place a 2 here. Do you agree? But because I was not just allowed to place anything I want, I mean, the problem is, as stated, I need to compensate. I compensate by multiplying by 1/2. Do you see 1/2 and 2? They cancel each other out. So now it's 1/2 times something that looks like a perfect chain rule. And all I have to do is find the antiderivative of root x. What's the antiderivative of root x? It's the antiderivative of the power 1/2. That would be 1/2 plus 1, which is 3/2 times 2/3. And this is the 1/2 that compensated. So the result is 1/3 to x plus 1 to the power of 3/2. Do you see, guys? You can do that in a second without any U-substitution, without any procedure. You do that momentarily by realizing I can make it a perfect chain rule and just finding the antiderivative for the outermost function. Here is the same process, but it's actually the same idea, but I use mechanical techniques to carry it through. So I will set u to be 2x plus 1, which means, again, I recognize what is the inner function. U stands for the innermost function. Good? So u is 2x plus 1. What is the u? It's 2dx. But I only have a dx, so 1/2 du is dx. So then I replace dx by 1/2 du, and this root, it's just root of u. So do you see what I accomplished? I now see 1/2 times the root. Just like over here, I realized I only need to take the antiderivative of the root. Yes? And then I have 1/3 u to the power of 3/2. That's the antiderivative of the root. Plus c, and then I just replace u back in terms of x. Yes? Let's see if you get this technique, guys. Could you tell me what's the antiderivative for the next example? First, without using U-substitution. I mean, you can use any technique you like, but let's see if you can just look at it and right away tell me the answer. U is always the inner function, Francis. All right, I don't know why it takes forever. Let's do it together. It should take you 2 seconds to figure such questions, guys. 2 seconds. Let's see this expression. So this is 1 over 1 minus 4x squared. And here I see x dx. Now, what is my eye looking at? You see, I see x squared and I see x. Do you agree? X squared and x. So what is the box that I want here? What would I really like to see instead of x here, guys? Could anybody tell me what to place here in this box? What number? -8. Thank you, Francis. Very good. I want here a -8, and I hope it's not because you looked into my notes below, but actually understood it. Yes? Do you see why -8? Because, guys, because this will serve well as inner function. You agree? If I take the derivative here, I will get -8x. So I can make it look like chain rule. If I cannot make it look like chain rule, of course, the situation is much more complicated. But it's not difficult to make it look like chain rule. Now, if I place a -8, I never had a -8. I then multiply by -1 over 8 to cancel it out. You understand? So that's my way. So what happens then? This is simply -1 over 8. The integral of this expression to the power of -1/2. And here I have -8x dx. And then I ignore everything except the -1/2. You see, my focus is entirely on the -1/2. Yes? And so what's the answer? The answer is 1 minus 4x squared to the power of 1/2. And to bring it down, it has to be a 2 here. 2 over 1 over 8, it's -1/4 plus c. And I'm done. It wasn't difficult. Yes, guys, you see, I mean, and I was explaining this. You could do that in a second. Now, what would it be using U-substitution? So this is without U-substitution. Here is the -8, here is the -1 over 8, and I right away figure the answer. Where is the -8? But Francis, you just yourself said -8. Didn't you just yourself tell me -8? Why do you put a -8 there? Because it's a perfect chain rule. I can ignore the derivative of the inner function. It disappears. It disappears. It's just when you take derivative, right? If I take here, for instance, suppose I begin taking the derivative of sine of x squared, right? I take the derivative, look, pay attention to the chronological order of how the symbols appear. First, it's the derivative of sine, right? So it would be cosine x squared, you see? Now, next appears 2x. Yes? So let's see what would happen if I want to go in reverse, right? So if I begin with cosine x squared times 2x, I just go in reverse. So what happens in reverse? Look at it, guys, and look at the video. First, what happens? You see, just if I play this video in reverse, this disappears. Yes? And then what happens next? This disappears and becomes sine. I mean, sine of this expression. Antiderivative of cosine is sine. I just go back. So the derivative of the inside is just ignored. You have to focus on the antiderivative of the outer function. Clear? Guys, is it clear? Try to to not look at my notes just ahead, just to guess it, but see that you understand the strategy. That's very important, guys. You need to do that fast for the exam. This is a trivial question. What do we have here now? We have here the same idea, but expressed using U-Substitution. So U, the inner function, I recognize to be 1 minus 4x squared, this thing that I put in the box here. Then du is minus 8x dx. And therefore, x dx, the thing that I have here, I have an x dx in the original expression, is simply minus 1 over 8 du. And so what do I get? I get 1 over root u minus 1 over 8 du, which simply becomes 2 root u times minus 1 over 8, which is minus 1/4, 1 minus 4x squared under square root. Very quickly, guys, with whichever method you prefer, figure out the antiderivative for e to the power of 5x, please. Very good, Humaira. Come on, guys. Fast. And the answer is, the question is, this is the integral e to the 5x. What do you want to be in the box, dx? Why do you want to be in the box here? Five. And what do you? And if you have a box in the 5, then you have to compensate it. You see, because there was no box. Nobody allowed you to just insert anything like I began in my introduction, right? So the box is, you pretend the box is there, you place what you want, and then you pay for it by the reciprocal, by 1 over 5. You can place, you can change by a constant, you see? Now, what do you get? Now, this integral is perfect chain rule. The outer function is, of course, here you can see the outer function. It's e to something. So the antiderivative is e to that same something times 1 over 5 plus constant. We are done. Good. Now, very quickly, guys, this is the next integral. I want the answer almost immediate. Tell me what's the answer. Should be in 1 minute. It should be as long as it takes you to type. Very good, Humaira. And the others, why it takes you so long? Yes. Look at this question, guys. What do you need here? I just wrote the, you see, 4 and 3. You right away think that must be the inner function. Here it is. Yes? So what am I missing? I'm missing 4 here and a 1/4. So the answer is simply the antiderivative of cosine, which is sine of x to the power of 4 plus 2 plus a constant, and don't forget the 1/4 that we produced. That's the answer. Agreed? Now, this one is slightly more complicated, maybe. Guys, can you figure out the integral of tangent x? My suggestion, a small hint, is remember the tangent is sine over cosine. That will help. Tangent is sine over cosine. Figure the integral of tangent. Careful. Very good. Zvi, there is a small mistake. Small mistake, Zvi. Can you find it? Come on, guys, fast. Imagine it's the final exam. Very good, Humira. Don't forget the plus C. Very good, Zvi. All right, guys, let's correct the situation here. What happens? Sine over cosine, 1 over cosine, and then what I have here is sine. You see, it's 1 over cosine and sine. But we require a minus. Do you agree? Derivative of cosine is minus sine, not sine. So I put a minus and I put a minus outside. And what do I get? Now it's perfect chain rule. It's just the antiderivative of 1 over something, which is ln absolute value of something. And there is an extra negative. I can move the negative to the power and I can make it ln absolute value 1 over cosine, which is ln of absolute value secant. Yes? So let me, I'm not sure if you manage to solve it in the time given, guys. Why is it outside? Because I can push the negative, I can push a constant outside of the integral sign. Why? Because derivative of a constant times a function is just the derivative of the function by itself and then multiply by the constant. So I only need to figure the antiderivative of the constant multiplied out. There was no U. I didn't use a U substitution here, right? So use careful language. The reason it moves out is that I have this property. if I want to take the derivative of a constant times the function, look what happens. I take the derivative, and then the derivative travels to just the function f and leaves the constant alone, which means that if I see constant times the derivative of a function, I can ignore the constant and I can just take the antiderivative of the function. So that means that this was -1. I could have written it like this. I could have written -1 over cosine x minus sine x dx. Yes? I could have written this. But the thing is, what it means, find the antiderivative of this function, which means it's the same as finding the antiderivative of this function, which means it's the same as -1 over cosine x minus sine x dx. You see why I move it out, because to find the antiderivative of this whole function is the same as to find the antiderivative of the function and take the constant out, multiply the constant later. You understand? It's obvious by the language. Now, I'm not sure if you are you able to do it my way, or are you able to do it using U-substitution? Which way you think has been faster? Of course, my way. I mean, you probably thought there is no other answer. You think there is a right or wrong answer. Well, U-substitution can be useful in some cases, like the next one. What is my way again? My way is just recognize its chain rule and reverse it. Right? And U-substitution is doing the same thing, but makes it mechanical. Here, on the other hand, guys, is a more difficult question, which on first glance does not look like it's relating to chain rule at all. And I think this particular question is easier to do using the U-substitution technique. Let me try to explain to you how I solve this. Okay, first of all, you look at it, does it look like a U-substitution? It seems not to look like that, right? Because this is, if this is the inner function, then 2 and 5 are not in any nice way related. Do you agree? We have x squared in essence, and then we have x to the 5. So how is it chain rule? Here, on the other hand, what you can do, guys. You ready? So I am going to say, let u equal to square root of 1 plus x squared. I made the entire thing be u. Then what happens is that u squared is equal to 1 plus x squared, and then what you have is 2u du, I take the derivative of this function, is equal to 2x dx, which means u du is equal to x dx. Okay? Now, let's look at what this means for the particular function we have here. So if this is u, then what is x to the power of 5? Well, x to the power of 5 dx can be written as x to the power of 4 times x dx. Yes? So I just need to, I know that x dx is u du from this equation. Yes, from this equation. You follow? So I know this is u du, and then what is x to the power of 4? X to the power of 4, well, I can go and look into this equation. I see u squared minus 1 is x squared. So u squared minus 1 squared will be x to the power of 4. Yes? I have it all typed below, so let me erase it and go down. Here it is, guys. Do you see this? X to the 5 dx is x to the 4 x dx, which is x squared squared times x dx, which is u squared minus 1 times u du. So this entire expression becomes u times u squared minus 1 squared times u du. And then I multiply everything through. Like I say, what is it? It's u squared multiplied by u squared minus 1 squared. So when I expand it, I get a polynomial in u, which is easy to integrate. So this would be 17 u to the 7 plus, oh, sorry, it is minus here. So it's, I roll the minus here. So it's plus minus 2 over 5 u to the 5 minus 1/3 u cubed plus c. And then I replace u by its original value. U was root of 1 plus x squared. So u is 1 plus x squared to the 1/2. So it's 17, 1 plus x squared, 7 over 2. And here I have 5 over 2, and here I have 3 over 2. Yes, now what was the idea, guys? What was the idea? I'm not sure if you would, after I explained it, understand it, but here is the problem. Do you see that with this root, I mean, I cannot easily distribute one way, right? In other words, I mean, I can move x to the 5 underneath the root, but that's not going to help me at all. Yes? So the idea is I want to view root of 1 plus x squared as one whole piece. You see what happens? This was 1 plus x squared roughly, and this was one letter. What did we do? We made it one piece, and then it became more letters on the x to the 5. You see, here is the x to the 5 part, and here is this part. Do you see? I change perspective. With respect to x, we have here a radical, we have here a fraction. But with respect to the fraction, you see, look at this fraction. With respect to the fraction, this expression is an integer. You understand what I mean? It's basically it's a matter of, let's say, basically when I say, well, you look like if I am, roughly speaking, it's not exactly that fraction, but if you see a root, then I am 1/2 of 1 power, right? So what is 5? When I look at power 5, with respect to me, it's like to the power of 10. You understand? X to the power of 5, if I am x to the 1/2 power. You see what I'm trying to say? Let me try to write it for you. So you have to think of perspectives. That's what a lot of people are completely incapable of doing, either in peer-to-peer conversations or in mathematics. They're not capable of seeing anything from the point of view of anything else. But here, that's exactly what this is doing. Look at it. X to the 1/2 against x to the 5, let's say, right? So this guy is saying you look like a radical. Yeah, you look like a radical. And what about this guy? He looks at him and he says, you look like power 10. Not 5, but power 10, because this guy needs to be raised to the power 10 to become x to the 5. Do you understand? Are you with me, guys? Yes? X to the 1/2, if I made it u, look what if I made it u, then what is this guy? This one is then u to the 10. So if it's u and u to the 10, now what does it achieve? I now have integer powers everywhere. You understand? X to the 1/2 and x to the 5, I have I have fractions. But if I make x to the 1/2 one whole, then I have a comparison between integer powers. And that's why this problem works here. You see, here we had a radical and an integer power, and I converted it where there were only integer powers. Okay, so that's an application which you can, of course, do it my way, but I think if you think in my way, it would be symbolically more complex and it's harder to accomplish. You understand? So that's one instance when I personally prefer U-substitution. But in other instances, when I see chain rule, I never bother with U-substitution. I do it faster. Now, the situation, guys, is you remember that if you're integrating, that's another thing when you can use a U-substitution here. When you're integrating a chain rule, look what happens. If you integrate a chain rule, it's just from a to b. It's a definite integral. Then you find the antiderivative, just any antiderivative, and calculate it from a to b. And you plug b, you plug a, and you have your evaluation. But look what happens. If I plug b and a, I have f of gb minus f of ga, which is the same as fu. GA, U equal to GA, U equal to GB. There can be limits for integrals, so you mean improper integration. But here we are just dealing with something simpler, right? So what is this? This is just the integral of f prime u du with the letters GA, GB. You can use it if you want to or not. I mean, it's up to you guys. You can just always solve those integrals, definite integrals, by finding the antiderivative and plugging the bounds. But you can also switch to a U-substitution and don't need to go back. So for example, suppose I want to integrate from 0 to 4 root of 2x plus 1. Yes? So I set it equal to u, and du is 1 half du is dx. So there is the 1/2 part. And then what I do is, instead of keeping the bounds, I see that here x is 0. That means u is 2 times 0 plus 1, which is 1. And if x is 4, then we have 2 times 4 plus 1, which is 9. So I can convert it to the integral 1/2 from 1 to 9 root u, and this is the answer. You see, just calculate it from there for 1/9, and that's the answer. You can do any way you like, guys. Tell me what's the integral from 1 to 2 of dx, 3 minus 5x squared. What's the integral here? All right, let's calculate it, guys. It should be quick and easy. So we can do it using U-substitution. We can do that directly, you see? You are right if you got 1 over 14. Here is how you do that. Here is how I would have solved this problem if I were doing it, yes? So I look at this expression. It's 3 minus 5x and squared, right? So what is this? This is integral from 1 to 2. 3 minus 5x minus 2 dx. Now, I am not happy with this expression. I want here to be what number? What number do you want? Quickly. Minus 5. And then here I have minus 1 over 5. And so the answer is minus 1 over 5, 3 minus 5x to the power of minus 1. And the minus drops now. I don't need the minus anymore, because it's minus here, right? So this is the function I have, and I can write it from 1 to 2. And then I just plug in 2, so it would be 1/5, parentheses, plug in 2, it would be 3 minus 10. So 1 over 3 minus 10. And minus, plug in 1, so it's 1 over 3 minus 5. That's it. And I'm done. You can simplify it and whatnot. The minus 2, what minus 2? I took the antiderivative. It was minus 2, so I integrated it. The antiderivative of something to the minus 2 is something to the minus 1 with a negative. I carried out anti-differentiation. Yes, so this is what you get. And you can do that using U-substitution. Because the antiderivative, it's not positive. So the antiderivative of minus 2, it's minus this thing to the minus 1. And there was an extra minus 1 over 5 multiplying it. So minus and minus, they cross out and become plus. All right, so you see, you could have also done this U-substitution, which is what I carried here. Now, very quickly, guys, with whichever method you like, calculate this. Integral from 1 to e ln x over x dx, please. I would like the solution like in 1 minute. At least the antiderivative and then the plugging in. Well, it's already 2 minutes and I haven't seen answers. What's the solution? Look how long it should take, guys. So this is ln x to the power of 2 divided by 2, evaluated from 1 to e. The answer is simply 1/2. Should take you nothing to solve those questions. Should take nothing to solve those questions. Here is with ln x over x. What is this thing? It's the integral from 1 to e ln x. And if this is ln x, then in the box must be 1 over x dx. What's the power here? 1. So what's the antiderivative? It's this thing to the power of 2 times 1/2. What goes in here? ln x. What do you write? 1 to e. Yes? Then you plug e, you plug 1. Yes? Does it take longer than 1 minute? No. It should take you a few seconds to see that right away. Yes, guys? So when you're trained well with it, it should take you, you just look at this. This is the type of question that is too obvious, okay? A second, like this. You can do that using U-Substitution as well. This is here I do it using U-Substitution just to show you that you can change the bounds of integration. But I mean, if it is dangerous, guys. I know that some of you, if you do that U-Substitution, you will forget to change bounds of integration, and then you will make a mistake. You understand? If I do a U-Substitution here, look what happens. U is ln x. Du is 1 over x. So then I realize I have to integrate u du. But from what bounds? It used to be x0 and x1. Now it's ln of, that used to be 1 and e. So now it's ln of 1 and ln of e. So that's 0 and 1. So it's the integral of u from 1 to 0. And that's the answer. Now let's practice together, guys, very rapidly. I want you to quickly tell me A. I want it to take 1 minute. One minute for A. Almost, Francis, you made the one small mistake. Yes. Well, you made, Francis, you made a small mistake. I think, yes, I think you mean, I'm hoping just write it once more for me to be sure that you understand it. Small mistake in A. And yes, Francis. Yes, Humira. Come on, guys. It's already longer than a minute, I think. Come on. Come on. Longer than a minute should be like this. And the answer. And the answer is ln x cubed over 3 plus c. Yes? Because what do I see here? I only see that I need to square, or I need to integrate power. You have to write c because it's any plus any constant would be would work, right? For any constant, take the derivative of a constant, it will work. So you should have a habit of writing c. You can get some points off, not from me even. Now b, guys, b should look at it and should take you, and you're done. But I'm giving you a minute. Not quite, Francis, that's not secant squared. For B, what's the answer, guys? Good, Jahin, you got it. And don't stop, go right away to the next question if you are done. All right, and the answer is, look at it, guys. Derivative of tangent is secant squared. So I see that the only thing I need to pay attention is the 3. So I should have simply tangent to the power of 4 theta divided by 4 plus c. I'm done. You see, I only needed to find the antiderivative of the biggest power, right? Secant is the secant squared is the derivative of tangent. So again, this is tangent. Look at it, the tangent of theta raised to the 3rd power. That's what this means. And then we have secant squared theta. That's what fits in the box. You see, derivative of tangent is secant squared. So all we need to deal with is the 3. So that becomes 4 over 4 plus c. And here I place tangent. You see the strategy? I mean, it just it's done in a second if you know what you're searching for. I want c. We just take the antiderivative. We just need to integrate the outer function. So what goes here? One minute. Almost, Francis, maybe a modification is required. Not just minus cosine, but it's good getting there. Very good, Lumira. Now let's look at this question again, guys. Let's look at C. So we have here root x sine 1 plus x to the power of 3 halves dx. What's missing here? What do I want to have here? I want to have here 3 halves. Do you agree? Because if I have the 3 halves here, then that's perfect chain rule. But I don't have a 3 halves, so I multiply by 2/3. And now everything is very easy. Now the antiderivative of sine is minus cosine. So it would be minus 2/3 cosine 1 plus x 3 halves plus c. Clear? Yes, guys? Understand now what's happening. Recognize it. So it takes a second. If you recognize chain rule, you understand what happens here. And think in your mind, do you realize why I only pay attention to the outermost function? This is the outermost function. Why do I pay attention to it? Because if you take the derivative in chain rule, you can see first you write the derivative of the outermost function, then you put the inner function, then you multiply by the derivative of the inner function. And if you reverse the process, if you watch the video in reverse, then you see the derivative of inner function disappears. You have derivative of outer function with inner function, and then the outer function without the derivative. Yes? Can you imagine in reverse, guys? Can you imagine watching this video in reverse? Yes or no? That's too bad. D. Sine root x over root x. Please calculate rapidly. All right, so what do we place here, guys? So what's missing here? You see derivative of root is 1 over 2 root. So it's missing a 2 here, and therefore a 2 here. So the answer is minus 2 cosine root x plus c. Did we get that? Yes. Good. Next one, guys. E. Very quickly. What's the answer? All right, very good, Zvi. All right, guys, it should take again. How long does it take? What is this missing? This is missing, and I'm not sure where to put it. I'll write it here. It's missing ln 5. So this is the outer function. So the answer, and if it misses ln 5, then I have to write 1 over ln 5. So the answer is minus 1 over ln 5 sine of 5t plus c. Good. I didn't cancel anything out, Francis. We're not in an algebra class. We are doing integration. I reversed the operation. I saw it's chain rule and I reversed the operation. Did I said sine and it should be cosine. Yes, my apologies. It should be cosine. Correct. Okay, guys, if you have a lot of questions, by all means, stay in office hours where I will try to explain it very slowly. Right? We can look again at the same idea a million times, but then stay in office hours for us to do that. Now, F might be a difficult question for you guys. Can you figure out F? So F, G, and H are difficult questions, I think. I will give you 3 minutes for F, and I'll be right back. Hello guys, how are you doing? Did you solve it? So what has been happening as I was gone? Any news? All right, let's solve this then. We are doing f, guys. So I can break it apart into two equations. 1 over 1 plus x squared dx plus integral of 1 over of x over 1 plus x squared dx. You agree? Yes. So what do we do here? So this part requires a 2 and a 1/2. And now we can easily solve the entire thing. So this is tangent inverse, first one, tangent inverse of x, plus the next one is 1/2 ln of 1 plus x squared plus a constant. Yes? Do you see what I did? I just simply distributed the 1 plus x squared to 1 and to x, and I have the first expression is just arctangent. Second expression is it's chain rule. It's 1/2 ln 1 plus x squared. Next. Next. Next is this. Integral of x squared root of 2x. What do you think would be the strategy for G, guys? Any ideas? I mean, I don't want to wait too long. What's the strategy? U sub, very good, Humira. You see, guys, x squared root 2 plus x. Do you see that? We have a power 2 and a fraction, and we would like to avoid fractions. Yes, we would like an integer power that would work here. So here is where I prefer U sub. So I'm going to set U equal to, anybody help me, what is U here? U would be what? Yeah. Good. The entire thing, guys, not just root of that. Because U is what I try to make a whole. I don't want to see the fraction, right? I don't want to see the 1/2 power. So I make U the entire thing. U is root 2 plus x. And then what do I do, guys? I don't take the U, I just square it. You see, I say take U squared is 2 plus x. And then we have 2u du is equal to dx. Do you see that? 2u du is dx. So then what else do we have here? And then we have x squared. What is x squared? X squared is u squared minus 2 squared, right? So u squared minus 2 is x squared, you would have x squared. So what I now get is an integral of u squared minus 2 squared times u times 2u du. And that becomes a polynomial. You understand? I can expand it and it will be a polynomial. And then instead of writing it here, let's look at solution G. You see, guys? What do I get? I get u squared minus 2 squared times 2u squared because of that. You understand what I achieved? I saw a fraction 1/2. Now, although I have to expand it, I don't see fractions. And then when I expand this polynomial, I get u to the 7 minus 4u squared plus 4 times u squared. distribute that, and I have this situation. Yes. So and then I can easily integrate it. No, we cannot take a break. There is no time for breaks anymore. Understood? And then the rest is easy. Yes, guys, the rest, I mean, you just expand and simplify, and that's just integrating a polynomial. From this step, I don't want to continue explaining. Can you please figure out what to do in H? You don't need to finish it, just tell me the expression that I will integrate once I am happy. And the answer is, guys, the answer is, what do we do here? What's U? U is what? Yes, essentially x squared plus, right? So it's root of x squared plus 1. U squared is x squared plus 1. And let's see how we get x cubed. So what we have is 2, so 2u du 2x dx. U du is x dx. Yeah. And so what do we get? We have here and so we have here yes, it was not there was not x, yes, it was x cubed, yes, that's right. That's right. So what do we have here? We have that u squared minus 1 is x squared, right, from this line. And we have that u du is x dx. So then I can look at this expression, and I can look at it and see x squared root x squared plus 1 x dx. And then what is it becoming? It becomes x squared here becomes u squared minus 1. This is u, and x dx is u du. So the integral is simply integral of u squared minus 1 times u squared du. That's it. Everything afterwards is distributed, and you have a simple integral. Understood? And this is all the calculations. Here we have a bunch with definite integrals. Okay, I will leave it to you to figure out. We did enough of those, yes? I'm gonna move to new topic. Understood, guys? But calculate those when you go home. It's not insignificant for you to be very good at U-substitution. Good? In both definite or indefinite integrals. Now, of course, the main goal of anything I ever explain is to talk about the purpose of it, right? So we just did calculations, but we have no understanding what those calculations mean and what's their purpose. So here is the problem that is called finding area under the curve. So in this section, we introduce the second main problem of calculus, and that's area under the curve. And for that, first and foremost, I need to introduce sigma notation. Guys, and this is just a convenient way to write a sequence of sums. So for example, AK, sigma k1 to n, it's like it just means start with k equal to 1 and then plus upgrade k to the next one. You see, so k is 1, then k is 2, then k is 3, and onwards until n. Yes? So in expanded form, let's just look at it, guys. What is 1 over k, where k is from 1 to 5? This formula means 1 over 1 first, plus 1 over 2, plus 1 over 3, all the way until I get to 1 over 5, until I get to the last number. Make sense? What is this expression? It means I begin with 3, and I will go all the way to 6, and I multiply the number that I am at by 2. So this would be 2 times 3 plus 2 times 4 plus 2 times 5 plus 2 times 6, which I can also write as 6 plus 8 plus 10 plus 12. And those are sums of even numbers. It's a sum of even numbers, yes? Now, what about this? From 6 to 6, k is equal to 6 and adds at 6. That means that there is nowhere to upgrade. It's just 6 cubed. So c is just 6 cubed. Understood? Started from a number and ended at the same number. Now here I start with j squared, where j is minus 2, and it has to reach 1. So that means minus 2 squared plus minus 1 squared plus 0 squared plus 1 squared. I just begin with this number, and I upgrade by 1 until I get to this number, and I use that expression. Yes? What do you think, guys, before I say it myself, what do you think is this summation? I equal to 2 all the way to 6 of 5. What is that going to do? Well, that means I add this expression all the way until I reach 6. Yes? So this is what it means, guys. Just the same idea. Here I is 2, I write 5. Plus I is 3, I also write 5. Plus I is 4, I also write 5. So it's 5 added to itself, starting at 2 all the way to 6. How many times am I adding 5 to itself? 6 minus 2 plus 1 times. You understand? 6 minus 2 is how many times I add after I passed 2. And then plus, why do I take extra 1? Why is there a plus 1? Because I also have to include the step I started with. So 6 minus 2 tells me how many steps are there once I left position 2. how many additions are left. So there are 6 minus 2 additions left beyond 2, plus the 1 addition at 2. Do you follow me? So it's 6 minus 2 plus 1 times 5. Now here we have another thing, something like s equal to minus 3 to 0 of e to the power of 2s minus 1. And you can see its powers of negative and odd. So it's, I put minus 3, I put a minus 2, a minus 1, and a 0. Yes? And I get this expression. Now, how do I convert into sigma notation if I have this addition? 2 plus 3 plus 4 plus 5 plus 6 plus 7. In your text message, guys, you can say something like S for sigma, and then you can tell me, let's say something like k equal to something, then comma, last thing that k equal to. So that's first, last, and then semicolon and expression. You understand how you can answer this question? Yes. So you can write S, then k, little k equal to something, then comma something else. That would be the top number, and then the expression. Can you tell me in the comments what is 2 plus 3 plus 4 plus 5 plus 6 plus 7 in this notation? And the expression is okay. So and maybe use k small as big. So k is 2 all the way to. You can just say all the way to 8. K is 2, and then comma last number is 8. And what expression? What am I adding? So this is the answer, guys. It should be summation. For instance, there are several ways to write it, but one easy is k equal to 2. There was a 7 at the end, right? To 7. And of what expression? Of k. Yes? Of k. And you could have written it like this. Big S, k equal to 7k. Maybe 7 semicolon to indicate this is k, or something else to indicate the expression is k. Good. In the text box, if you want to write, you can write the solution this way. So I know that you understand it should look like that. Now do the same thing for b. Can you figure out the summation where it's 1 plus 3 plus 5 plus 7 plus 9 plus 11? What is that summation, please? Obviously, there are many ways of writing it. Yes, guys? So here is one way to write it. So notice that this one, I can make an odd number is 2 times an even number, let's say -1. Do you agree? So then how do I make 1? What should k be when it's 1? K should be equal to 1, right? So I have summation of 2k minus 1, and here I have k equal to 1. What should be the last number here? Very simply solved, because it's 2k minus 1 equal 11, which means that 2k equal to 11 to 12, which means k is equal to 6 for the last number. Yeah, so the last number should be 6. K should be 6. Did you understand what I just did here? Those are not consecutive numbers. Those are consecutive odd numbers. 1, 3, 5, 7, 9, 11. Yes? And I can represent an odd number as 2 times a number, because 2 times a number makes it even, -1 makes it odd. So 2k minus 1 goes through all odd numbers. Now, if I am grading just k, then to get 1, k has to be equal to 1. And then to get all the way to 11, 2k minus 1 has to equal to 11, which means k has to equal to 6. Do you understand? You can either just right away see it or just solve this formula. 2k minus 1 is 11, 2k is 12, k is 6. Now, very quickly, how do I figure out the summation 2 plus 4 plus 6 plus 8 in sigma notation? Those are even numbers. Where do I do? Okay, it's me. So 1, 2. Okay, the expression is 2k, good. So it goes all the way to 4. So for C, the answer is k1 to 4 of 2k. Do you agree? So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. You are with me, guys? Okay, Humira, take care. Thank you for staying. It's too bad to lose you. I will have fewer quick answers. Bye. You can, of course, guys, create another, for the same problem, there is not a unique solution, you see? I can write k equal to 0 all the way to, if it's from 0, then maybe all the way to 3, and then I can write here something like 2k plus 2. Yeah? Do you agree? So there are all many different ways of describing the same thing. There is no unique sigma notation for an expression. All right. D, it's a summation of just -2. What would it look like in sigma notation? Very good, David. So it's just summation k equal to, let's say you can say 1 to 4 of simply -2. You're just adding -2 until k reaches to 4. Yes? And do you understand how to get to the other ones, or should I go through the rest? Right, so you have a bunch of fractions. Here is for fractions, it's 1 over k. H is for even fractions, so actually, no, it's 1/4, 1/9, 1/16, 1/25. Yes, so those are what? 4, 9, 16, 25. Those are squares. So H is a summation of squares, 1 over k squared. And this, look at it, I, it's 3, 6, 9, 12, 15, 18. Those are multiples of 3, right? 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6. So it's how I got 4. 4 for what? I'm sorry, Giovanni. For which question? For this? For C? For D? Because 1, 2, 3, 4. I add until when k goes from 1 to 4, k is moving through 4 numbers. And each time k moves up a number, I add a -2. Good? Everybody understands, guys? So we have 3k. There is nothing special about the letter k, it's just an expression. I prefer to use it over the letter I because I to me means square root of -1. But you can, in the book you see some expressions like I equal 1 to 6 of 3i. Good? Again, there is nothing unique about the summation. So for example, the sum k 1 to 6 of k squared could also be written as the sum from k3 to 8 of k minus 2, because you see here I subtract 2, so in essence this number is the same as the number is 1, then the number is 2, then the number is all the way to 6. You see, those two expressions, they mean exactly the same thing. And then we have the following properties about summation. So if I begin summing from some integer m to the integer n of something that looks like ak plus bk, it will be separately the sum of ak plus the sum of bk. And why is that true? It's very obviously so. Look at it. It's evaluate at m, evaluate at m plus 1, evaluate all the way to n. And because addition, I can just group. I can sequester a to the left parentheses and sequester b's to the right parentheses. And then you have the left parenthesis becomes this in sigma notation, and right parenthesis becomes these in sigma notation. Are you following, guys, that the summation of sums is going to be a sum of summations? Yes, it's very obvious, and it has to be very obvious, guys, because those s signs that we just did integration, we did mindlessly. I am going to try in the whatever amount of time we have until the exam to push the concept into your minds. Okay, because everything else complete nonsense. If you don't know concepts, this is a meaningless thing that you were doing. And so another thing is, of course, if I add terms where they have a common c, a common constant, I can factor the constant outside the summation. You can see that easily because if I expand it, I have c times everything, and then I factor the c out, and I have in parentheses the sigma sum. So I can move constants outside the sigma. Yes? Now, guys, it will be necessary for us to find simplifications, right? I would like to figure out a formula that does not involve addition. So in some cases, this is easy. So I have summation where k is m all the way to n of the letter a. So that's a added how many times? It begins with m, then it's m plus 1, then all the way to n. How many times am I adding a to itself? Look at it. I wrote in blue the number of times a is added to itself. You see, it's m plus 0, m plus 1, m plus 2, all the way to m. To make it n, I can make it m plus n minus m. Do you see in blue? So it's n minus m, but there is an extra one. So there is n minus m and plus 1. Are you with me? You see, so for instance, if what I'm saying, guys, is the following, right? I'm saying that, let's say, if I have a summation where k starts with 3 and ends in 5 of, let's say, the number 2, what should I be getting? My claim is that you will get 5 minus 3 plus 1 multiplied by 2. That's the number you will get. So you will get the number 5 minus 2 times 5 minus 2 times 2, you will get the number 6, I'm claiming. You understand? How do I know you get the number 6? Or how do, in general, when I do this process, when I do the summation process, you see it here, I look at what I'm adding to m. Now, here I need to add 0 to m, here I need to add 1 to m, 2 to m, and to get to n, I need to add n minus m. Do you see that? N minus m is what I need to add. So then I can just count. From 1 to n minus m, I have added a n minus m times. And there is an extra where you see the 0, there is one extra time I added the a. So altogether, n minus m plus 1 times a was added to itself. Yes? So I have a very easy formula when it's a constant. Here is that formula. The next guy, guys, is another not a very difficult formula, summation of consecutive integers. So k1 to n of k, it's a summation of consecutive integers. Good? Now, how can you figure out this summation? There is a legend that in the, well, you might say it was in the later part of the 18th century, there was a very cruel German teacher, math teacher. Usually when I talk to some Germans, they all had a cruel math teacher. And this math teacher tortured his pupils by making them add numbers 1 through 100, for instance. And when they made a mistake, you know what in that day what you do? You discipline. You take a rod and you hit them on the hands. Yes, unfortunately, this is not the way to go today. That's why education is so terrible. All right, so no, it doesn't help, truly. You see, I mean, you know, a donkey doesn't become smart because you hit it. So truly, I don't believe in it. So there was one student that answered it correctly instantly and without making a mistake. That student was Carl Friedrich Gauss. He would say just right away, they would not write it on paper. They had like a small board, right? A small board, like a small blackboard chunk, and they would write there. So he would just go like this, hier steht's. Here it is, the answer, right? And then he actually got it correct and instantly. His name was Carl Friedrich Gauss. This teacher, it was just a farm, sort of like a farm boy, somebody from a low class, but the teacher was able to recognize that this little boy is a genius, and he became one of the most notorious or famous mathematicians that ever lived. A very, very important mathematician with far-reaching theorems, even ones about time and space. So how did Gauss calculate it so easily? Well, obviously, because he did not do it like the students. A lot of people, what they do, they just go 1 plus 2 plus 3 plus 4 plus 5. And of course, if you do it this way, it will take you forever. What did Gauss do? Look at this, guys. Here is something that you could do yourself. You could have figured that out yourself. So I can write the summation as 1 plus 2 plus 3 and onwards in increasing order. You agree? At the same time, I can write the same summation in decreasing order, right? So n plus n minus 1 plus n minus 2 all the way in descending order. Observe that if I place the summation one below the other, I can look at 1 and n, at 2 and n minus 1, at 3 and n minus 2, and you see this one loses a number and this one gains a number, which means that an integer, right, a 1 unit. Which means that this is simply n plus 1, this is n plus 1, this is n plus 1, this is n plus 1. Each term is n plus 1. Do you follow? So if I take s plus s and I add them up like this, they form a very nice pattern. Do you see it, guys? S plus s, the summation is just gives you 2 times s. But in the columns, I have n plus 1, n plus 1, n plus 1. How many times? First, second, third, all the way to the nth time. So I add the number n plus 1 to itself n times. So 2s is equal to n times n plus 1. Do you understand what I'm saying, guys? I am obtaining a very, very quick formula. So what I'm saying, guys, 2s is n times n plus 1, and s, therefore, just divide by 2 is n times n plus 1 over 2. So that tells me, for instance, that if I had to sum 1 plus 2 plus 3 all the way to 100, the answer is simply 100 times 101 divided by 2. Yes, as simple as that. So yes, so that would simply be 50 multiplied by 100 plus 1, and that would be 5 with 3 zeros plus 50. So altogether it would be 5050. Understood? I can very quickly then calculate. Any questions on how I figured it out, guys? You see, if you understand the idea, if you truly understand the idea, then you don't forget it. If you remember steps, then it's a lot of information to keep in mind. Here is an example. We have 10 diplomats and they are in a meeting. Each diplomat has to shake hands with each other diplomat exactly once. How many handshakes take place? Figure it out, guys. Set it up. You understand, 10 diplomats in a room. Each diplomat, you take a photograph. Each diplomat shakes the hand of each other diplomat exactly once. How many handshakes? Be careful, guys. Well, how many handshakes? David says 90, but remember what's the formula, right? I mean, first of all, what's the summation, and then how do you reduce that sum? Should take you 2 seconds. Let's do it together then. The answer, David, is 45. You were almost there, but you made a mistake. So how many handshakes? That I can do this like this, guys. So first guy, diplomat number 1, will shake hands with the remaining 9, and then be gone. He's already shook hands with everyone. There is no reason to shake his hands again, right? So diplomat 1 carries out 9 handshakes. He's gone. Diplomat 2 carries out 8 handshakes. And then all the way to diplomat 9, he will carry exactly 1 handshake. So it's 9 plus 8 plus 7 all the way to plus 1. So how do you add it up? It's 9 times the number next after 9, which is how you got 90, but you forgot to divide by 2. You see, because you calculated s plus s. You see, n plus 9, n plus 9, n plus 9, 9 times is just when I place one by one at the side of the other. And then it's 2s, but I need to divide by 2 to get s. Clear? Are you still, guys, oxygen in your brain still coming? We need to be much tougher, right? Now let's talk about, I mean, it's not the season, but let's talk about no oxygen, Anna? No what? No oxygen? You need something, guys? Some refreshment, some respite? Guys. Take off then the mask first thing. Are you wearing it by any chance? Maybe that's why you have little oxygen. You see, it also makes up the brain die. Are you wearing 2 masks? Well, everybody can use more brain cells. So guys, take a deep breath. Maybe let's do a jumping jack. What do you say? We stand up, 1 minute of jumping jacks, and then we continue, right? I want to be universal, right? So let's do, we're doing gym then. Stand up, turn on the camera, and we're going to do something like this. Quickly, come on, stand up, do this, and then afterwards you will solve 20 problems. No? No? You want to do push-ups, or you want me to do push-ups? Will that? Actually, I injured my shoulder. I should be careful about push-ups. But anything for you guys, if that will make you awake. What do you need? Become alive, guys. We have no time. Are you ready? Stand up, maybe do a handstand, do anything, but be ready and be able to think. Get some oxygen. Exactly, we need to continue. Oh, here we go. Let me show you my walker, right? I have a walker. This is for my old age. Good? Do we have oxygen now? Let's go. Now, guys, time to get biblical on your butt. The menorah has 9 sockets for Hanukkah candles. The holiday runs for 8 days. On the first day, you light 2 candles. On the second day, you light 3 candles, all the way until the 8th day. I believe, correct me if I'm wrong. Did I write it correctly? It's right. On the last day, you light 9 candles. Maybe I miscalculated the candles. Good? Correct? So 9 candles on the last day. I need you to tell me what's the minimal number of candles that should be in a box so that I'll be able to have 1 box for the entire holiday. Because you understand, first day you consume 2 candles, second day 3 candles, all the way until the 8th day you consume 9 candles. Calculate, please. Svi, do you know it right away or did you calculate? You can.
I knew the answer anyway, but.
But you calculated? Or you just knew the answer?
I'm getting the point of the calculations also.
Good. You speak Hebrew, right, Svi?
A little bit. Not. I speak Yiddish better than Hebrew.
I see. All right, guys, so let's calculate it together then, right? We don't have time. We are rushing through the entire thing. So the summation is just 2 plus 3 plus 4 all the way to 9. The only thing we don't like is that we're missing a 1, right? So S plus 1 is the summation that's very easy to calculate, right? So I add 1, and then the result is like with the diplomats, it's 45. You see, S plus 1 is 45. Subtract 1, you get 44, and C was right. Do you understand, guys? You can say 1 plus 2 plus 3 plus 4 all the way to 9, and that would be 45, but we don't have the 1, so take it out. Clear? And now, guys, I want you to do something more challenging, or less challenging, actually, in my opinion. So it's 9 plus 1 over 2. It's when I start the summation from 1. Do you see where we get this idea, guys? This is where we were inspired. You understand the inspiration? Is that if I draw the sequence in ascending order, and here I have it in descending order, the columns add up to the same number, namely n plus 1. The last number plus 1 is the column. But if I add this together with that, I just get twice the sum. So the sum must be n times n plus 1 divided by 2. It's a very, very quick idea. Now, I want you to verify that you understood this idea by adding up the summation where I don't begin with 1, but any arbitrary integer m. So from m to n, what's the summation of the consecutive numbers? To check if you understand it. So I want you to give me a formula for this example. I want the full summation, what it equals to, not just that. So for the summation is already written in sigma form, this one. I want you to tell me what's the answer. In closed form, without sum, what's the answer? Or better, guys, if you're thinking, what's your idea? How would you figure the summation? All right. So very simply, what's the idea, guys? It should be very quick. The summation is m plus m plus 1 all the way to n, which is m plus n minus m. So what am I adding? I'm adding m together. I can do it in several ways. I can do it like before, or in one column against another, or I just see it's m plus 0, m plus 1, all the way to m plus n minus m. So how many times am I adding m? M is added to itself n minus m plus 1 times. And here I have 1 plus n minus m. So that would be n minus m multiplied by the next number, n minus m plus 1 over 2. And when I combine it, I get m plus n times n minus m plus 1 over 2. You can also do that using this two lines. It's the same thing, but just start with m all the way to n. You understand? It should take you a few seconds. You just you can align it. If s is equal to this expression, then it also is equal to this expression, yes? You understand? Reverse the sum. Instead of writing it forwards, write it backwards. When you add it up, it gets to be the same number, and column-wise, you are getting the number n plus m. So it's really simply, why is the answer the way it looks? M plus n is the value of summing in the column. Each column adds up to n plus m. And how many times am I adding that column? I'm adding it n minus m plus 1 times. And I divide by 2 because I have 2 sums here, and I want 1. I hope this is clear, guys. And I hope, of course, you know, that's not many pages, 15 pages for this document. You should be reading my notes. Yes, you should be reading my notes, guys. Don't be passive about it. You should have watched the videos I sent. Definitely by the final, we need to be in good shape. This summation is now a bit more difficult, summation of the k-squares. So it's 1 squared plus 2 squared plus 3 squared all the way to plus n squared. Okay, so you can actually figure out what it is, guys. It's very amazing with combinatorics, because what it means, guys, is that I might have 2 brothers that are younger than me. And my age is not known. My age could be very young, it could be very old. It's like a riddle, right? So how many possibilities for the age? So my age, I mean, I am at least 2 years old, and at most n plus 1 years old, and I have younger brothers. Okay, and I'm not going to go through the logic of doing that this way. It's very nice and beautiful and quick proof. Here it is. I just mentioned it, and you get very quickly the answer to be 2n plus 1, n plus 1n over 6. But you can also do it as follows, guys. So first, we already have the Pascal triangle. We know how to cube numbers, yes? So I am actually going to solve it as a telescoping sum. So summation, I'm going to consider summation of k plus 1 cubed minus k cubed. So what is this thing? On one hand, guys, it is, I can do it in 2 ways. So you see that this is 2 cubed all the way to n plus 1 cubed, minus 1 cubed, 2 cubed, 3 cubed, 4 cubed, all the way to n cubed. So the summation on one hand is equal to n plus 1 cubed minus 1 cubed. Do you understand? Simply because I realized that here I am adding the numbers 2 cubed all the way to n plus 1 cubed, and here I'm subtracting numbers 1 cubed all the way to n cubed. So I subtract essentially everything except from here I don't subtract the last term, and from here there is nothing to remove the first term, k equal to 1. Did you understand how I quickly got n plus 1 cubed minus 1 cubed? Or are you completely lost? Yes. What is the sum, guys? The summation, here I do it in several ways, but the summation is k1 to n k plus 1 cubed minus the summation all the way to n of k1 to n of k cubed. Yes, what is that summation? What's the summation of the first term? Look at it. If I plug k1, it's k plus 1. So its first term is 2 cubed. Next term is 3 cubed, right? All the way to until I get to n cubed, n plus 1 cubed to be precise. And then from that I subtract. What do I subtract? 1 cubed, 2 cubed, 3 cubed, n cubed. Yes? If I subtract, what survives? The only thing that was not subtracted out is the last term, n plus 1 cubed, nothing cancelled. Do you agree? 1 cubed, 2 cubed, 3 cubed, 4 cubed, all the way to n cubed. This contains everything up to from 2 to n. Yes, so it was subtracted out. So that is n plus 1 cubed. And from here, there was no 1 cubed cancelling this one, so it's minus 1 cubed. You understand? So this summation is very quickly, if you interpret what it means, It's called telescoping sum. So although it looks scary, it's actually nothing more than n cubed, n plus 1 cubed minus 1 cubed. Yes, I do it here. I'm trying to show you another strategy in doing it here. But you can read it later, okay? So this is the result that I get, n plus 1 cubed minus 1 cubed. And when I simplify it, I just cube it. It's n cubed plus 3n squared plus 3n, and then plus 1 minus 1, it's this expression, okay? So adding it like that, what I just said, it's this expression. On the other hand, what else can I do here? I can expand the k plus 1 cubed minus k cubed, and when I expand it, what do I get, guys? I get 3k squared plus 3k plus 1. You understand? So if I simplify it before I add up, I just simplify within the k's, I get 3k squared plus 3k plus 1. So the summation of 3k squared plus 3k plus 1 equals to n cubed plus 3n squared plus 3n. But what is it? What is the summation equal to, guys? I mean, it's the summation of k squared times 3 plus 3 times the summation of k plus the summation of 1. Let me, before I continue, are you with me or completely lost? In this case, I create an equation. In that equation, I solve the problem in two ways. In one way, why do I consider k plus 1 cubed minus k cubed? Because when I expand it into the k, I will have a formula of k squared. So I will have an equation. Do you see what happens here, guys? If I simplify what's in the bracketed parentheses, I get 3k squared plus 3k plus 1. That's what I will get if I simplify it. Notice that the cubes disappeared. It's 3k squared plus 3k plus 1. And then if I distribute the sum, do you see, this is what we want to find. I want to find this expression. This expression times 3 plus 3 times this expression. I know the value of this expression. It's n plus 1 over 2. Term by term summation. So it's n times n plus 1 over 2. And this thing is n. So what do I get? I get that 3 times the summation plus, plus this expression. I just multiplied it through and I have this expression. And that would be equal to basically just substitute and solve. Understand? So this is what we know, then we know the others, and we know what this is equal to. And then of course the problem, guys, and if you are with me, you should at some point try to solve the cube. I think it's pointless. I see people are just disappearing, they're leaving me. Then I suppose goodbye then. If you need to leave, you need to leave. Lessons over for today. We will have, I presume, at least 2 more lessons. Whatever we manage to capture, guys, there is still a lot of material. You should read all the notes. You should look at the videos as I mentioned. If you have questions or if you want to play what, when, where, you stay. Other than that, take care. The next lecture is, I think, Tuesday. I think I'm going to use Tuesday and Thursday. We will continue into the final week using Tuesday and Thursday. And Sunday, we will have a review. Right? So Sunday around 1:30, I will send you a message. Sunday at 1:30, be ready to do a review. So I'll message when. But it will be Sunday 1:30 most likely, right? So good.